Dear students, welcome to this session. In this session, we are going to talk about lab program number 8. Develop a program to introduce 2D array manipulation and implement matrix multiplication and ensure the rules of multiplications are checked. In this first thing is it is going to be a two-dimensional array. One dimensional array is it is indexed by only one index. In case of a two-dimensional array, an element will be accessed using two indices, okay, I and j. So normally you had one dimensional array with just one index, you can access the every element. In case of a two-dimensional array, you can access the element using two indices I and j. That is the one concept we are going to learn in this particular lab. Also, since a matrix can be represented as a two-dimensional array, we will be doing the matrix multiplication. First, we will understand the problem statement. This is the problem statement. Then we will talk about the logic. The problem statement is very simple. We have to do a matrix multiplication using a two-dimensional array. First, we will understand the matrix multiplication. Matrix multiplication, I have considered here two matrices, matrix A, this is matrix B, and we are going to do the multiplication. When matrix A, it is represented by the each element is represented by the row and the column. Suppose A00, what it means is this is element is in the 0th row and 0th column. All the elements in this particular row will have a 0. So A0, that is the first index. So how do we access this matrix? Using two indices, I and j. I value is 0 to its size, and j value is its 0 to up to its column number of columns. So here we have 2 into 3 matrix. We have 2 rows and 3 columns. The first element is A00. Second element is A01. What is the meaning? This is the element at the 0th row and first column. Next one is A02, element at 0th row and 2th column. Similarly, this is the second row. Second row is represented as A10. This is the row number 1 and column 0. A11, row number 1, row number column number 1. This is row number 1 and column number 2. This is how we represent. Why we started with a 0 is, in case of a array, we know that index starts with a 0. That is how we have taken. So this is 2 by 3 matrix, and 2 is m into n. In general terms, we can say it is a m into n matrix, and this matrix will be multiplied with another matrix B having 3 rows and 2 columns. 3 into 2. You can see P into Q is the order of the second matrix. M into N is the order of the first matrix. And when the matrix multiplication is possible, matrix multiplication is possible only when the number of columns, that is n, the number of columns of the first matrix is equal to number of columns of the number of rows of the second matrix. So when we can do the matrix multiplication? Only if number of columns of the first matrix is equal to number of rows of the second matrix. Or we can say, if m into n is the matrix A order, P into Q is the order of the matrix P. If n is equal to Q, that is here you can see 3 is equal to this 3, then only we can do the matrix multiplication. Otherwise we will say matrix multiplication is not possible. Let us assume n is equal to P. This particular case, how to find the multiplied matrix? The first element of the multiplied matrix is calculated using the first row of the matrix A and the first column of the matrix B. So C00 will be calculated as is equal to A00 into B00 plus A01 into B10 plus A02 into B20. So basically we will multiply this row with this column with the respective elements. So this is multiplied with this, this is multiplied with this, and this is multiplied with this. Addition, sum of all those will become the first element at C00. And how do we calculate the C01? If we multiplied the first row with the second column, same multiplication rule, we get the C01. How to calculate C10? Next one, the second row into first column gives the C10. Second row into second column gives the C11. So if you see here, what we end up with when we have 2 into 3 matrix multiplied with the 3 into 2 matrix, we end up with a 2 into 2 matrix. That is, we end up with M into Q matrix. Whenever we do the multiplication of M into N matrix with P into Q matrix, we end up with M into Q matrix. So that equation I have given. So you can see multiplication is possible only if N, that is number of columns of the first matrix, is equal to number of rows of the second matrix. So these are the formulas C00, C01, C10, and I hope you understood the logic here. I have some more values here that we will discuss when we talk about the logic part. We are going to use that part. Okay, so in general you can see here C00 is sum of the multiplication of the first row of the rows of the first matrix into the columns of the second matrix. So if I say this as a Ij, Cij is equal to sum of Aik into Bkj. Okay, we'll go through the code, then we'll come back here, then we will understood what are these values. These are with respect to the program that we have. Okay, now we'll see the program. In the program, you can see we start with the hash include stdio.h main. Okay, and this is the start of the program, and there is a respective closing bracket would be there. In this case, we would require 3 matrices. First matrix is the matrix A, which we read from the user. Second, matrix B, again we read it from the user. Then C is the matrix where we store the multiplication of A and B. Here you can see A, after A we have 2 pairs of the square bracket representing 2 dimension. If I have only 1 pair of square bracket, that means it is 1 dimension. 2 pairs of a square bracket means 2 dimension. So we have an array called A, which is a 2 dimensional, and its maximum rows can be 20 and maximum columns can be 20, and the name of the array is B. Similarly, I have one more array B and one more array C, 2 dimensional with a maximum of 20 rows and 20 columns followed by semicolon, and these elements are of the type integer. So that is the declaration part of the all the arrays. Then we have we need many indices and values to store the rows and columns. All of those values will be integer type. So we have m comma n. M comma n is the order of the first matrix, and p comma q is the order of the second matrix. I, j, k we will use as a indices in the for loop. Now the first thing is we will ask the user to give the order of the matrices. You can see here Okay, read the size of the first matrix. So you just print a message to the user saying enter the order of the first matrix. So user will give the order, two numbers he will give, m and n. So scanf inside the bracket %d, that is it's going to read two integer variables followed by comma ampersand m comma ampersand n and semicolon. Whatever the two numbers user gives, that will be stored in m and n. Again we will print a message saying enter the order of the second matrix, and we will do the scanf, and we will store those numbers into variables p and q. Now user has given the order of the first matrix and also the order of the second matrix. In the example we saw, we had a 2 into 3 matrix. That means 2 is m, 3 is n, and we had 3 into 2 matrix, that is p is 3 and q is 2. Now the first condition we have to check before doing a multiplication is we have to check whether n is equal to p. The number of rows, a number of columns of first matrix is equal to number of rows of the second matrix. If this condition is true, then only we will do the multiplication. So this if statement, inside the true block we have all the instruction related to the multiplication, and if this condition is false, what is the meaning of that? We cannot do the multiplication. Directly I will go to the else, and then we will come back to the true block. Let us say if n is equal to p, this condition is false. Means what? Number of columns of first matrix is not equal to number of rows of the second matrix. If that condition is false, we will directly come to the else part. You can see the else part. If it is else, then if that condition is false, the statement will come here. It will print the matrices cannot be multiplied, and this is the end of the program. It will stop here. Now let us say if n is equal to p is a true, we will go back to the same if statement. We will say this is condition is true, then it will come inside. Once this order is, this condition is true, then we will read both the matrices. And you know, for reading one dimensional array we use one for loop. For reading two dimensional array we have to use two for loop. Scanf will be used inside the two for loops. Enter the first matrix element, that is what we are going to say. For I is equal to 0, I less than m. This represents the number of rows. In our case it is 2 into 3 matrix. I less than 2, then I plus plus. Inside that for loop we have another. Basically this first for loop I is for representing the row, the next one representing the column. So we start with the 0th. For I is equal to 0, we start with the 0th value. 0 less than 2, it is true, it will come here. Then we go through the all the columns, j becomes 0. Now we have scanf statement, %d ampersand of a I j. What is the value of I and j? I is 0, j is 0. That means it will read the first element a00. So I is 0, this is 0. So it will read the first element a00. We will go back to the, okay. So it will read first this element a00. After that, this is the j value will increase to 1. Is it happening there? Okay. Once it reads, user gives the value, again it will go back to this. It will increment the j value to 1. 1 less than, in our case n is 3. 1 less than 3, true. Again it will come here. What is the value of I? 0, and j is 1. So it will read the next element a01. Right? After that again j is incremented to it was 0, then 1. Okay, now it is 2. 2 less than 3. Answer is true. It will read again ampersand of a of 0, 2. 0, 2, next element. Now j value will become 3. 3 less than 3. Answer is false. Now it will come to the next row. I will increment to, from 0 it will increment to 1. 1 less than 2. Answer is true. It will come here. J is 0 initially. 0 less than 3. True. Now it will read A of I value is now 1. 1 0. It will read A of 1 0. Then J will increment. It will become 1. A 1 1. That is the next element. And J will increment to 2. That is A 1 2. A 1 2. It will read the next one. Now J value will become 3. 3 less than 3. False. So it will go back here. It will increment. I value was 1. It will increment to 2. 2 less than 2. False. So we are done with reading all the elements of array A, isn't it? Now next, reading the second matrix. Here in the second matrix, P is the maximum number of rows and Q is the maximum number of columns. So how many elements we are going to read? P into Q. The same logic what we discussed here, that will go here. I will go from 0 to P minus 1. J, for each value of I, J will go from 0 to Q minus 1 and it will read into B array B. Okay, two-dimensional array B. So it will, how many elements it will read? In case of our example, we had P as 3 rows and Q as 2 columns. 3 into 2, 6 elements it will read. So if you see here, it will read B 0 0 0 1 1 0 1 1. So this is the ith value. Once we have the I, it will J will go from 0 to 1. Once we have the value of I as 1, J is 0 to 1. Once value of I is incremented to 2, J will go from 0 to 1. That is how we read the both the matrix. So reading part is very simple. Once you understand the reading part, the next, the whole heart of your logic is inside this. Means I would say, if you understand this part, or if you memorize apart from the regular reading of the matrix and displaying the matrix, this is the important manipulation you are doing, or the multiplication you are doing. So here you have to remember, we have to use 3 loops, one loop inside another loop. So we have 3 loops. The outer loop will run from I is equal to 0 to I less than m. And what is m? These are the number of rows of the first matrix. So value will go from 0 to 1 less than the number of rows of the matrix A. Then inside that I have the second loop, which will go from J is equal to 0 to J less than Q. And what is Q? Q is number of columns, P into Q. So the second matrix order is P into Q, number of columns of the second matrix. So J will go from 0 to Q minus 1. And inside this is the whole logic. We are going to calculate the elements of the multiplied matrix. So whenever we are doing this, first initialize to 0. Cij is equal to 0. So let us start with our example. Initially I is 0. I 0 less than, this size is what? 2 into 3. 0 less than 2, true. J will become 0. Okay, 0 is less than 3. Answer is true. It will come here. I is 0, J is 0. So C of 0 0 initially it is set to 0. Then we come into the third loop, and this third loop is, it will start from 0 and it will be n minus 1. What is n? N is the number of columns of the first matrix. Now it will come here, and that is a 3. Okay, 0 less than 3, true. We come here. C of 0 0 is equal to C of 0 0. C of 0 0 is, we set it as 0, is equal to C of 0 0 plus A of 0, k is 0, 0 0 into b of 0 0. So we will go back to this diagram. Okay, so you can see here we did this first term a 0 0 into b 0 0. Next, the k value will increase. After doing this, k value will increase to by 1. From 0 it will become 1. 1 less than 3, answer is true. Now c of 0 0 is equal to c of 0 0. Now in the c of 0 0 what we have? We had the multiplication, this multiplication we already have that, a 0 0 into b 0 0 plus a of 0 1 into b of 1 0. So plus a of 0 1 into b 1 0. So this part is added to this part. Now what will c 0 0 will have? A 0 0 into b 0 0 plus a 0 1 into b 1 0. After that k value will increment to 2 and 2 less than 3, answer is true. So c of 0 0 is equal to c of 0 0. What is c of 0 0 now? Already we have two terms. These two terms are already there. Then plus a of 0 2 into b of 2 0. A of 0 2 into b of 2 0. If you see, then I will just go with the next value. K becomes 3. So 3 less than 3 is false, means it will come out of this for loop. At the end of this for loop, what has happened? We calculated the value of C00. So if you see that particular iteration, this complete value is calculated. And how it started? Outer loop. We have the outer loop where I was 0 and inner loop j was 0 and inner to inner loop, loop number 3. The k value goes from 0 1 2. That is how it happens. So I will show you that diagram. Okay, if you see this calculation, C00, a of I, this is k, into b of kj. So effectively I can say Cij is equal to sum of aik into bkj. And in this particular case, I value is 0. You can see I value is always 0 and b value is always, it is 0 because we are calculating for 0 0. So 0. And if you see the k value is 0 here, k value is 1 here and 2. So it is incrementing 0 1 and 2. So we have first outer loop where I will run from 0 to, this should be m minus 1. Loop number 2, j is equal to 0 to q minus 1, and loop number 3, k is equal to 0 to n minus 1. So this is how we are going to calculate each of the values. That is what I have shown here. Okay, now let us try for the next element, this element. In this element what happens? This loop is completed. Now it will go to this, j will increment to 1 less than 3, answer is true. So it will come here. C of I value is still 0 1. So we are going to calculate C of 0 1 is equal to 0 initially, then k will go from 0 to 2. So initially k is 0. C of 0 1 is equal to C of 0 1. Initially it is 0 plus A of 0 0 into B of 0 into 0. So you can see that C 0 1 is equal to A into 0 0 into B into 0 1. Okay, sorry, I value would be j value would be 1 because it is already incremented. So C ij is C 0 1 is equal to C 0 1 A 0 0 into B 0 1. That is what we find here. Clear? In the next, so that value is stored into C of 0 1. Next k becomes 1. So C of 0 1 is equal to C of 0 1. So we had earlier term plus A of 0 1 into B of 1 into 1. A of 0 1 into B of 1 1. Then this term is added to this. Now C of 0 1 has these two terms. Now k value will become 2. So C of 0 1 is equal to C of 0 1, A of 0 2 into B of 2 1. So you can see A of 0 2, B of 2 1. So what you are seeing here, I value remained same, it is in the outer loop. J value incremented to 1 because we went this one loop increased, and after for I is equal to 0 and J is equal to 1, K will again go from 0 to 2. That is how it will calculate C01. Now once these two are done, number of rows are done. Now I value will increment. So it will loop here. Once this is done, so initially I is 0, J is 0, and it will loop here. Once it completes, I will remain 0, J will increment to 1, again K will loop. Once J is done, because number of columns are done, then this loop will go back to this loop will stop. Then I value will increment to 1, again J value will go from 0 to 1 for I value 1, and for each value of I and J, K will be going from 0 to 2. So we have outer loop for the I and one more loop inside that for the J, and we have one more loop inside loop number 2, that is loop 3. That is how we do the repeated calculation of sum of all these products. Okay, so this is the representation. So important formula you have to remember is one thing you have to remember is what is the maximum value you have to take here. For this outer loop is M, second loop Q, and third loop is N, and this formula Cij is equal to Cij plus Aik into Bkj. So I into K, Kj. If you remember this formula, rest of the things would be very easy to understand. Now after all these loops are complete, okay, once this outer for loop completes, that means we went through all the possible values of the multiplied matrix and all possible values of the third matrix, that is multiplied matrix, is calculated. Now only thing is to display the multiplied matrix. How do we do the display the multiplied matrix? Again, for displaying we need two for loops. We have for I is equal to 0, I less than M, I plus plus, and when we multiply the matrix, the resulting matrix is going to be M into Q. Okay, so that's why we have M rows and Q columns, and you can see for I is equal to 0, J is equal to J less than Q, J plus plus, we are going to print %4d Cij. Cij is already calculated, and %4 means %d we already know, it is a format specifier for the integer. %4d means it will allocate 4 spaces, so the display would be neat. Otherwise you can use %d and check how it looks. Now for one row, so I is equal to 0, this will print one row, so 0 will go from all the columns 0 1 2 3, it will display all the row, and once that is complete, then we have a print statement. Okay, before going to the next row we have print statement, so that it will come on the next line, so the display would be very nice. So after every row I will print a new line and go to the next row. That is how I am going to print the matrix. So here very important part is for reading two matrices we need two for loops, and we use their respective order. And once we have two matrix ready, this is the heart of the program where the calculation is done, and this is important equation you have to remember. Cij is equal to Cij plus Aik into Bkj, where Cij, before the loop you set it as 0. That is important thing. And displaying a matrix, again 2 for loops. Only changes after every row you are going to print a new line, and after this it will stop it. Once this is the end of the true block, and it will stop here. Let us see the output, which is already executed. I will show the output, and we are going to run the program as well. So here is the output. Enter the order of the first matrix 2 3, and second matrix is 3 into 2. So this is 2 rows and 3 columns, 3 rows and 2 columns. So this is 3 columns and 3 rows. So this matrix multiplication is possible. And after that we are going to read the first matrix. How many elements are there? 2 into 3, 6. So 1 2 3 4 5 6. So this is how 2 rows into 3 columns. And then 3 into 2 matrix, 3 rows and 2 columns. Total elements are 6 again. 1 2 1 2 1 2, 3 rows 2 columns. And when we multiply this, we get 8 10 20 25, that is 2 into 2 matrix that we get. If you want to do one simple calculation, see, this is the first element. Let us calculate this into this. 1 into 1 plus 2 into 2 4, 1 plus 4, 3 into 1 3, 1 plus 4 plus 3, that is 8. That's how we get the element. Next, here you can see I ran the program once again. Enter the order of the first matrix. I gave 2 2, and second order of the second matrix 3 into 3. Now the matrix multiplication is not possible because number of columns is of matrix A is not equal to number of rows of the second matrix. So matrix multiplication cannot be, the matrices cannot be multiplied. That is the output you are going to get. Now let us see the execution of the program. Okay, I have entered already. As I said, we are going to use the JDoodle C online compiler, and I have already copied the program. All the complete program is here. Okay, now, so how to give the input? So let us give whatever the output I got here. Okay, if you want, we can give this matrix. First one is 2 3, and second matrix is 3 2. So input, first matrix is 2 3, and second matrix is 3 and 2. And what would be the first matrix? The first matrix is 1 2 3 4 5 6. 1 2 3 and 4 5 6. And what would be the second matrix? 1 2 2 1 1 2. 1 2 2 1 1 2. Now I am going to execute. So already all the inputs are given. I am going to execute. So I will keep the window for you. I will say execute. So you can see the output 8 10 20 25, which matches with our output. You can see 8 10 20 25. And let us try giving the incorrect matrix. I would say 2 2 3 3. Here I am not giving the input for the matrix. I know it, the program will not go there. Program will go to the else part and it will stop. See, the matrices cannot be multiplied. Okay, so this is a very important program. Please, if you don't understand, please go through the video again and try to understand the logic. It is very simple. Once you understand the logic and make yourself comfortable with reading and reading the matrices, how to read. So this is simple code reading, because most of the you can say 60% of the program is read and display. If you know the read and display, if you are very comfortable with that part, the calculation part, actual multiplication part is only this part. So where you see the this is the actual part where multiplication is done. Even if you memorize, then it would be easy for you to write this particular program whenever it is asked.